the first problem, it states the 8-pointed star shown in the figure below is a popular quilting pattern. What percent of the entire 4x4 grid is covered by the star? So in order to solve a problem like this, we basically need to find a percentage, or we need to find a ratio, and then we can multiply by 100. So we can set up the problem like this, that the percentage is equal to the area covered divided by the total area multiplied by 100. So now if we look at this shape that is given, so we are not given any of the dimension. So for convenience, we can take 1 for the side length, and then if I calculate the area of 1 square, that will be 1 unit square. And how many total square I have here? They are 16 if I count them. So the total area will become then 16 unit square. And now I need to find the area that is covered by the star. So that is now 1, 2, 3, 4. So I have 4 full squares, plus I see that I have 1, 2, 3, 4, 5, 6, 7, 8 half squares. So I can write like this. And now if I calculate the total area that is covered, so that is 8. And now to find the percentage, I can plug these values there. That is equal to 8 over 16 multiplied by 100, and that is then 50%. And the answer is then B. So now let's solve problem 2. In this problem, we are given ancient Egyptian symbols, and they are representing different numbers. As we can see down here, that there are different symbols and they are representing different numbers. So for example, a number 32, it is represented with this combination. So we can quickly see that by simply adding the corresponding numbers from this table, we can get 32. So now we have to answer that what number is represented with this combination. So for that, we will take again the corresponding values for each symbol and then sum them up. So we have 10,000 for the first one, then we have and then if we add that up, the answer that we get, that is B. So now let's look at problem 3. That is about a card game in which Anika and 3 of her friends are playing, and each player has 15 cards. And we have to find out when no 2 more friends join the game, so how many cards each player will have. So first, we will find the total cards. That is equal to 60, and for each player we will simply divide, and the answer is then 10. So C is the answer for this question. Let's solve problem 4. And in this problem, someone is counting backward by 7s. His first 3 numbers are 100, 93, and 86. What is his 10th number? So if we see the pattern of the numbers, we can see that they're decreasing and the decrease is constant. So as we can see, like 100 minus 93, 7, and similarly if we take the next one, we will get the 7. So to solve a problem like this, what we can do, we can simply apply the arithmetic sequence formula, and then what we have to do, we have to plug the values, and then if we solve, the answer will be 37. Okay, so now let's look at problem 5. That is about this street map, and it says that Betty starts at the factory F and drives to different locations and then return to F. And we have to find the shortest distance in blocks that she can drive to complete the route. So to solve this problem, we will go only along these lines that represents the streets. So we go like this, and then we'll take the other shortest path, then the next one, and then the last. So from F to A, we have 3 blocks. The next we have 10. And if we count these from B to C, it's 6 and 5. So now if we sum up, so we get 24. So the answer is C. Okay, so now let's look at the next problem. That says that someone writes the numbers from 15 to 19 and he raises one of his numbers. The sum of the remaining numbers is a multiple of 4. So which number did he erase? So to solve a problem like this, one of the strategy could be to simply take a sum of these numbers and then subtract 1 by 1 and divide by 4 and see that if the resulting number are multiple of 4 or not. So if we take sum of these numbers, that is equal to 85. So now if I start subtracting each number 1 by 1, I get 70, but that is not a multiple of 4. Similarly, if I do the next one, I get 69. That is also not a multiple of 4. So if I check this one, this is a multiple of 4. And if I divide 68 divided by 4, I get 17. So the answer is then 17 or C for this problem. Okay, so now let's look at problem 7. And in this problem, we are given score distribution for a class. And we have to find out how many scores they earned, at least 80% and less than 90%. So we can solve this problem by making a number line and then assigning the distribution. So let's say that this is 95%, this is 90%, 85%, and 80%. So now if you see, we are given that there are 5 students who earned a score of at least 95%. So there are 5 students for that. 13 students earned at least 90. So in this region, we have 13 students, and then there will be 8 here. And we have 85% students which are total of 27. And if we subtract 13 from 27, we get 14. And 50 students earned a score of at least 80%. So that means that we are having 50 students here. And if we subtract 27 from 50, we get 23. And now if I sum up 14 and 23, then I get 37, and that is the answer for this question. So now let's look at problem 8, in which someone cuts open a cardboard cube along some of its edges to form the flat shape that is shown up here. And it has an area of 18 square centimeters. So what is the volume of the cube in cubic centimeters? So the formula for the volume of a cube is this, and we are given the area for this shape, that is 18 centimeter squares. So if we see, like, there are 6 squares, and the area for each of that would be 3 centimeter squares. So what we can do, we can now find the length, and that is 3. And if we take the square root, then it becomes L is under square root 3. So now we can get the volume, that is 3 of 3. So the answer is then A. Now let's look at problem 9. And in this problem, we have to take average of each pair, and then we have to take average of the resulting numbers. So the first pair that we have is 8 plus 2. So if we take the average, that is 5. So for the next one, 6. And 4. So now what we will do, we will take the average of these 6 numbers. So that is then 5 plus 6 plus 7 plus 8 plus 9, 4 over 6, and that is equal to 6.5. So the answer is B. Problem 10. So in this problem, we are given a rectangle, and that is then rotated at 90-degree clockwise about its midpoint. So in this problem, we have to find the overlapping area by the two rectangles. So what we have to do in this problem, we will calculate the areas for both of those triangles. So we are given this length 5, this is 3. So we will have then area like 15 plus 15 before rotation and after rotation. However, we have to remove the overlapping area for one of the times. So for that, what we can do, since it is rotated around the midpoint, so this is dimension is 2.5. And if you see, like, then these dimensions, each of that will also be 2.5 and 2.5. So then what we will do, we will basically subtract this overlapping area. And now if we calculate, so we will have then 30 minus this number, so that would be, so we know 625 and then 6.25, and then we can simplify that, and it would be then 23.75, and the answer is then D. Now let's look at problem 11, in which a tetromino is given that consists of 4 squares connected along their edges. There are 5 possible tetromino shapes which are given here, and which can be rotated or flipped over. 3 tetromino are used to complete recover a 3 by 4 rectangle, at least one of the tiles is an S tile. What are the other two tiles that we have to answer? So we are told that one of them is S, so we can make, let's say, S tile here. Okay, so let's say that this is the S tile that we have. And now what we have to do, we will eliminate the other possibilities. So if we are putting S here, so it means that O is not possible, so we can eliminate this option. The second option that we can eliminate is T, because if we see, we cannot also fit T in this shape. If you put S here, we can also eliminate this option. And same, like we can use I. If we use I here, then we cannot use another I or L. So it means that this is also not possible. And now we can check the remaining option, that is L. So if I put L here in this direction, no, I can put L like this, and then I can also put second L like this. So by rotation, so now it will meet the requirements. So it means that our other two tiles, in order to make this rectangle, are L and L. Since for these exams we cannot have multiple solutions, so therefore we don't need to even check D, so you can leave this out. So the answer is then C. Look at problem 12. In this problem, we are given this figure that consists of 24 squares and each with side length of 1 centimeter. And we have to find the area of the largest circle that can fit inside the region, and it can touch the boundaries, but it cannot cross the boundaries. So the circle that meets these requirements, I have already drawn up here, that can be seen. Now what we have to do, we have to find the radius of the circle so we can get the area. So for that, what we have to do, we can draw a triangle, and then we can see that this is 1, this is 2, and this hypotenuse of this triangle, this is the radius. So the radius is equal to then 2 square plus 1 square, that is square root of 5, and the area is now pi r squared, pi this, and then that is 5 pi. Okay, so this is the answer, 5 pi. So now let's look at the next problem, that is about finding the number of times each remainder occurs. Now let's look at problem 13, that is about finding the number of times each remainder occurs when we divide even numbers from 2 to 50 by 7. So in order to solve a problem like this, it is better if we create a list of the possible remainders first. So we have 0, we have 1, 2, 3, 4, 5, and 6. And then we can simply list the number of times each remainder will occur. So for example, when we will divide by 14, 28, and 42, we will have a 0 remainder. And for 1, we will have 8, 22, 36, and 50. we will have 1. For 2, 2 will itself be there, then we will have 16, 30, and 44. For 3, then we have 10, we have 24 and 38. For 4, the options that we have are 4, 18, 32, 46. For 5, we have the options which are 12, 26, 40. And for 6, the options that we have are 6, 20, 34, and 48. So it may appear a bit daunting, but it is not difficult to create this list. The only thing is you identify the first one and then just simply keep adding 14. And I am adding 14 because we want to have the number even. So if it would be odd, then we can add 7 as well. So similarly, we can create the list. Now we have created the list, so we can see like how many times each of the remainder is occurring. So we have 3, 4, 4, 3. Then we have 4, 3, and 4. So now we can see like where we have this pattern. So this is 3, 4, 4, 3, 4, 3, 4. So then A is our answer for this problem. Let's look at problem 14, where a number is inserted into the list. The mean is now twice as great as the median. What is n? So we have to find n. So let's say the list that we are given is 2, 6, 7, 7, 8, and n. So the mean is now twice as great as the median. So the new median that we have, that is 7 plus 7 over 2, and that is 7 for this list. And the mean, that would be then 14. So now what we have to do, we have to find n. So we can find n by having 14 is equal to 2 plus 6 plus 7 plus 7 plus 28 plus n divided by 6. And then what we get here, if we add these numbers, we get 50 plus n over 6. And then we have 84 minus 50 n, and n is equal to 34. So the answer is then E for this problem. So now let's look at problem 15, where Kai draws a 6 by 6 grid. He colors 13 of the unit squares silver and the remaining squares gold. Kai then folds a grid in half vertically, forming pairs of overlapping unit squares. Let small m and capital M equals the least and greatest possible number of gold on gold pairs, respectively. What is the value of m plus m, meaning small m plus capital M? So, like based on the given information, we can see that he is folding the grid in half vertically. So that means he's making a cut here. And M represents the least number of gold on gold pairs. So there are silver squares are 13. So then gold squares are total 23. And the maximum pair that we can have on one side is 18, and similarly maximum we will have 18 on the other side. So for the M to have the least number of gold and gold pairs, we should have a maximum gold on one side, and that will be 18. So it means that small m then will have 18 and then 5 on the other side. So then we will have 5 as the answer for small m. But for the capital M, we want to maximize the overlap. So for that, we can divide this number by 2, that is 11.5. So this is then we can have then 12 and 11, and then the overlap that will be for 11, and then the sum of the small m and plus and capital M, that is 11 plus 5, and that is 16. So the answer is C. Now let's look at problem 16, where 5 distinct integers from 1 to 10 are chosen and 5 distinct integers from 11 to 20 are chosen. No two numbers differ by exactly 10. What is the sum of the 10 chosen numbers? So basically what we can do, we can list these numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have 11, 12, 13, 14, 15, 16, 17, 19, and 20. So if we see, the condition that is given is no two numbers differ by exactly 10. So that means we cannot have like these pairs, ones that I'm circling in red, because all of these pairs, if I go all the way up to 10 to 20, so they all differ by 10. So I cannot have these pairs. So what other options now I have that I can use is I can select any of the numbers. 5, probably I can take these, and then I can take 5 from here. Or vice versa, you can also take these 5, the one that I am highlighting in black, or you can take these 5s. And you can also take any of the other combination. However, regardless of that, the answer will remain the same. So let's take the ones that I circled in green. So I will then just write then 1 plus 2 plus 3 plus 4 plus 5. Then have 16, 17, 18, 19 plus 20. So now we can simply sum that up. So we have 20 already here, and now if you take this 19, 1, that will also give you 20. You take this 18 and 2, that is another 20. 17, 3 is another 20. And then we have what? We have 16 and 4, another 20. And then we can write 5 as it is. And the sum is 105. So the answer is then C. Let's look at problem 17, where we are given 3 cities, A, B, and C. There are 100 people live in A, 120 in B, and 160 in C. Everyone works in one of the 3 cities, and a person may work in the same city where he lives. And then it says an arrow pointing from one city to another is labeled with the fraction of people living in the first city who work in the second city. Okay, so let's first label it. We have 100 people here, and then we have 120 and 160. So first we find the people who are living in B and working in A. So that would be and then let's find the number of people who live in C and work there. So that is then, so we have 40 people here, and then we have 20 people here. And now we need to find how many people who work in A and also live in A. So that would be simply 100 minus 1/5 of 100 and minus that would be 1/4 of 100. So if I simplify, I would get 100 minus 20 minus 25. So that would be then 55. So now if I add all of that, I get 40 plus 20 plus 55. Then the answer is D. Now let's look at problem 18, where the circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the circle shown on the right, 1/4 of the region between the circle and inscribed square is shaded. The shaded region in the two circles has the same area. What is the radius R of the circle on the right? So to solve this problem, we will start with the small circle, and we know that the area of the shaded region, that will be pi r square minus the area of the square. So I'm representing this with S. So we are given the radius, so we can just simply plug that here. However, for the square, we need to find the lengths. So we can complete this triangle, and now this is a isosceles triangle, or 90, 45, 45, 90 triangle. So we can apply the Pythagoras theorem. So let's say this length is L, this is L. So we have L square plus L square is equal to 1 square, and 2L square is equal to 1, and L is equal to 1 over square root 2. So now if we need to find S, so S will be then equal to L plus L, that is equal to 1 over square root 2 plus 1 over square root of 2, then that is 2 over square root of 2 and square root of 2. So we can plug that here, and now we can say that it is pi minus 2. So now let's do the same thing for the right hand side. So on the right hand side we have pi r square, and then we are subtracting from there this circle, this square. Okay, so first we can do for the whole, and then we can apply for this only region. So if I do for that, I can again find this length and this length by applying the Pythagoras theorem. So again, if I apply, I will have then L square plus L square is equal to R square. 2L square is equal to R square, and then I will have L equal to R over square root of 2. And if I add, I will then get 2L, that will be equal to 2R over square root of 2. So that 2L actually represents this whole length of the edge. So I will then have 2R over square root of 2, and pi r square, that is now the area of the whole circle, and I am subtracting from there this. So I also have to now multiply this by 2R over 2. So then I will be having pi r square minus 4R square over 2, and then I'll have pi r square minus 2R square. So then the next thing is, since only 1/4 is shaded, so I will divide this by 4. And now I will put these two equal to each other and find the value for R. I have pi minus 2, that is equal to pi r square minus 2R square over 4. R square common, I will have pi minus 2, cancels out. I had 4 here and then 4, which gives R. So then this is how I can solve, and now the answer is 2. Problem 19. Where two towns A and B are connected by a straight road that is 15 miles long. Traveling from town A to town B, the speed limit changes every 5 miles, and the limits are given here. Two cars, one at town A and one at town B, start moving toward each other at the same time. They drive at exactly the speed limit in each portion of the road. How far from town A will the two cars meet? So to solve this problem, we can start with this formula, that is between the speed, distance, and time. And then in this problem, since both of the cars, they are taking the same time, so we can set up like this. Then time A is equal to time B. So since one car is going in this direction, the other car is coming in this direction, so then they will meet somewhere in this town. However, what we know, then they would have covered completely the first portion, like this portion and also this portion. So we can then write like, if I rearrange this, I can write it like TOS. So I can then write here 5/25, and then on the other side I can write 5/20. So now we don't know like where they will meet in this portion, right? So what we can do, we can then assume, let's say that this is, we can take it Z, and can take then this is 5 minus Z. So if we add that up, it is 5, right? So now we can add here that this is, the distance is Z/40, and here we can say plus 5 minus Z/40. Okay, so after that, all I have to do, I have to now solve for Z. So for that, like we can start simplifying. So if I do this, I get 1/5. If I do this, I get 1/4. And now I have 1/5 plus Z/40. And here I have 1/4 plus 5 minus Z/40. So then I can simply multiply this 10 by 10, this one 8 by 8. And then here I'll have then 8/40 plus Z/40. This one will be then 10/40 and plus 5 minus Z/40. So then I can have it 40, it becomes then 8 plus Z. Here I will have 40, and it is then 15 minus Z. So this cancels out, and then I will be left with 8 plus Z equal to 15 minus Z. And then if I rearrange, I get this, and then if I calculate, I will then get 7/2, that is 3.5. So answer will be then 5, that is from distance from this end, 5 miles plus 3.5 miles, and 8.5 miles will be the answer. So that is D. So let's look at the next problem. Sarika, Dave, and Rajiv are sharing a large block of cheese. They take turns, cut half of what remains, and eating it. First, Sarika eats half of the cheese, then Dave eats half of the remaining, and this cycle it continues until the cheese is too small to see. So we have to find out at what fraction of the original block of cheese does Sarika eat in total. So there are three people who are involved. One is Sarika, Dev, and Rajiv. So let's say that we are having Sarika, Dev, and Rajiv. And we're starting with one as a whole for cheese. So Sarika, she's eating half, and then they will eat half of that, and Rajiv will eat half of that. And in the next turn, then Sarika will eat 16th. This is 132, and then this would be then 64. And similarly, like this cycle, it will continue for all of them. So if we see like what Sarika has eaten, so we can write it like this. Sarika is 1/2 plus 1/16. Maybe I can add another term, so that would be 1/122, 8, and plus this sequence it will continue. So if I now change it to the power of 2, it will be like this, plus 1/2 to the 7, and plus it continues. So now I can again write it like this. So now from here I can see that this is geometric series problem. As we know, there are two type of series. One is the arithmetic series and the other one is the geometric. So this is the geometric, where we have the common ratios, and when we want to find the sum for a geometric series, the sum is equal to a over 1 minus r. So a is 1/2, 1 minus, and r is the common ratio. So that is then 1/8. And now if I solve this, I will have then 7/8. And if I further simplify, then I'll have 1/2 multiplied by 8/7. So I will be having then 4/7. So the answer is A for this problem. Okay, so now let's look at problem 21, where the school has assigned grades 1 through 7 to pods A through G, 1 grade per pod, that is shown up here. And it says the school noticed that each pair of connected pods has been assigned grades differing by 2 or more grade levels. What is the sum of the grade levels assigned to pods C, E, and F? So we have to find C plus E plus F, basically the sum of these three pods. So if we look at this diagram or the figure that is given here, in order to satisfy this condition, like each pod is differing by 2, we need to see like which of the pods are connected to the most other pods. So in this case, we are having C and F. So C is connected to 5 and F is also connected to the 5 other pods. So that means either C should take 1 or 7, and also then F should take either 1 or 7, because they are connected to 5 other pods, and we have to adjust, assign the values so that they are differ by 2. If that is the case, so then I can assign D a value of 6, and then I can assign G a value of 2. And now the choices that I have for A and B, they would be 5 and 3, and then I can assign now 4 to E. So now if I take the sum, that would be equal to 1 plus 4 plus 7, and the answer is 12. Let's look at the next problem now. It says the classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced so that there is the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose there is at least one coat and at least one empty hook. How many different number of coats can satisfy Paulina's pattern? So to solve a problem like this, first what we can see that every coat, it has at least one space before and one after. So it means that if we are having one coat, so then there are two spaces. And let's say now if we are having two coats, then we are having three spaces. So it means that if I am having x coats, then I will have x plus 1 spaces. So here we are given total rows which are 35 coat hooks. So that means that if I'm having 35 hooks, then if I subtract the coats and divide it with this plus 1, then I'm having the number of hooks equal to that. So now what I can do from here, I can rearrange this expression like this. And then I will have 35, that is n plus 1 plus x. And now I can have nx plus 1 plus n plus x, and I can add plus 1 here, and also I will add plus 1 here. So now if I take n common, I will have x plus 1 plus 1 and x plus 1, and then I will be left with x plus 1, and that will be equal to 36. So now in order to find like how many different number of codes can satisfy this pattern, so all I have to do is to make sure like which integers will satisfy this relation. So the relation that I have, that is $36. So what I can do now, I can plug a number and see if that works or not. So I will start with 1. If n is 1, so then x 17, that will make this expression true. If I have n2 and x is it makes it 3 and then 12, right? It is, then if I make it 3, 4, and then I can have 8 here. Now let's see, if I have 4, it will become 5, and then this 4 is not possible, so I will cross it out. So now let me check 5 and 5, that would work. 6 would make it 7, 6 will not work, 8 will not work, no, 8 will work. Anyway, 8 plus 1 and 3 plus 1, so 8 will work. What about 9 will not work, 10 will not work, 11 will work. So 12 will not work, 13 will not work, similarly 14 will not work, and if I check, then 15 will not work, 16 will not work, 17 will work. So then the options that I have, I will have 1, 2, 3, 4, 5, 6, and 7. So then the answer is D for this problem. Okay, so now let's look at problem 23 that says that how many 4-digit numbers have the following properties. The tens and ones are both 9. The number is 1 less than a perfect square. The number is the product of exactly two prime numbers. So it is a 4-digit number, and these are the nines, which are the ones and tens. The number is 1 less than a perfect square. So let's say if the number is, if we are taking it as a y, that is equal to 1 less than a perfect square. So it is then minus 1. And if I add this 1 here to this number, then it ends with 0, 0. And if that ends in 0, 0, it means that the only perfect squares that we are interested in are the ones that are ending in zeros. So the number that we are looking into, they are in this range. Okay. So now if I take the squares, so just to make things easier, I'm just going to take this one as a 10,000. So if I take the squares which are between this range, then they will start from 32 and they'll go all the way up to 100 for this one. Okay, 100 square. So since these are perfect squares, then the number that we are interested in, they are 40, 50, 60, 70, 80, and 90. And now what we can do, now we can, by applying the difference of square formula, we can just write it in this form, and then can plug each of this number and see that which one is a prime number. So if I plug the first one, I get 39 and 41. So if I do the second case, I would get 49 and then I get 51. The next I get is 59, 61. Then I get the next is 69 and 71. And then I get 79 and 81. And then I get 89 and 91. And now I can see like which of this combination is a prime number. First one is not a prime, so because 39 is not a prime, 51 is not a prime, this is prime, this is not a prime, this is not a prime, and this one is also not a prime number. So the only answer then I have is this, and then the answer is B for this. So now let's look at problem 24, where we are given a trapezoid ABCD, and it has two angles which are 60 degrees. The side lengths are all positive integers, and the perimeter is 30 units. And we have to tell like how many non-congruent trapezoids satisfy all of these conditions. So if we see like this trapezoid, it is a isosceles trapezoid, and we can divide this into two triangles which are the same and then one rectangle. And we can solve this problem by setting up the given parameter equal to the side lengths. So I can take this side length as x. This is also as x. If I take this one as an x, so then it becomes an x over 2. It becomes x over 2 because the triangle that I have, that is a 30, 60, and 90 triangle. So then I can take this side as is y. This I can also take as a y. So now if I sum that up, I will have x plus x over 2 plus x over 2 plus y equal to 30. And I can also write it like 3x plus 2y equal to 30. And now I have to see what options are possible for the values of x and y. Let's say list here x, here y. So one of the integer that I can take, or the positive integer for x, that can be 10, but then y is 0, so that is not possible. The next one, if I take 9, it becomes 37, so that is also not possible. The reason is we want this number to be even, because we have even here and we have even here, so we want 3x, like x will take a number so that it turns this product to be even. So therefore this is also not a possibility. So let's try 8. If I have 8, I can have 24 and plus I can have 3. So yes, 8 and 3, yes, that could be one option. Then again 7 will not be the option, and I will just cross that out. 6 could be another option, and it will be 18, and then I need 6 and 6. And then I can have another that could be 5 will not work, 4 will work. 4 and 9. And then I can have 3 will not work again, and 2 will work. So 2, and then I will have 6, and then I can have 12. So then the total number of possible options that I will have is 1, 2, 3, and 4. So 4 is the answer for this question. If you just wonder like why I didn't include 1, because that will also make this odd and that will also not work. Let's look at problem 25, where Michaela finds all the possible ways to draw a path in a 5x5 diamond shaped grid. Each path starts at the bottom of the grid and ends at the top. So basically it's starting here and it is ending here. Okay. And it says she computes the area of the region between each path and the right side of the grid. Okay, 2 examples are shown in the figure below. What is the sum of the areas determined by all possible paths? So it means that we have to find sum of the areas that would be then equal to number of paths multiplied the area per path. So to solve this problem, we can see that she is taking either steps towards northeast or towards northwest. And she is taking 10 steps, 5 in this direction and 5 in the other direction. So the total steps that she's taking are 10, and there are 2 possible directions, and in each direction she's taking 5 steps. So then she's having 5 possibilities. So then the total number of paths that she will have, that is equal to And then if we simplify, we can get cancels out, and then we can simplify this. So we have so if I multiply, I will get then 936 multiplied by 7, and that is, so I will get 252. See now how we can calculate area per path. So we are having 252 paths, and it is very difficult or not practical that we calculate area for each of the paths. So what we can do, we can make an observation. As we know, like there are two areas we have divided into. One is white and the other one is the shaded. So if I divide this square with this diagonal line, and then I can notice that each path, it will have an inverse path. So for example, if I reflect this path about this line, then I will have this path that is a reflection of the other path about this line. So that means that for every two paths, the area is equal to 25. So in order to calculate then the total area, I can simply divide the total number of paths by 2 and then multiply by 25. If I solve this, I will get 3150. So that is the answer for this question.